All right, I guess that's about time to get started. Uh, Hello, everyone. My name is Simeon Vincent, and I'm a developer relations engineer with Mozilla, working on the add-ons platform. Today, I'm going to be sharing a bit about browser extension development and targeting cross-browser extensions in Manifest v3. And I'm realizing now that my slides are in the wrong place. So let's start from the beginning. Doing it live. That's the beauty. There's always a chance to discover something new that you forgot to do. uh, and let's share my screen. So today I'm going to be doing a bit of live coding and walking you through the process of actually building up a browser extension in Manifest v3 that will work across multiple different browsers, specifically Firefox, Firefox for Android, and Chrome. Safari is also supported, and but we're not going to be getting into the demos of Safari for time reasons. So first, let's establish a baseline. What are browser extensions? To put it simply, they are small applications that run in your web browser that modify how the browser looks and behaves. For example, we have a couple of extensions that we're going to take a look at on addons.mozilla.org or AMO. First, we have tree style tabs, which adds a vertical tab bar to your browser. And as you browse the web, it will collect your tabs into a tree based on the page that was used to open them. So this kind of changes your basic feeling for how you use a browser extension. We have uBlock Origin, which is a very popular browser extension that allows you to, or very popular content blocker that allows you to hide content that you don't want to see on the websites you visit. And we have Dark Reader, which is an extension that will enable you to use a dark theme on websites, even if the site author didn't actually implement one themselves. I want to pause real quick because I realized that I hadn't yet started a Q&A. So I'm going to leave this link up for most of the talk. That way, when you are, if you have any questions that you'd like to share or discuss when we get to the end of the talk, I'll be going through these questions at the end. All right, let's get back to it. So here you can see an example of Dark Reader Hacker News by default, and then with Dark Reader enabled, you have a nice look and feel that still respects the site's original design. Now, web extensions are the common term that's used for cross-browser extensions. Over the years, there have been a number of different models that web browsers have exposed to enable users to customize the way their browsers look and feel. And the common model that all the different browsers are aligning on is called web extensions. We're also working together, the different browsers are working together in the web extension community group, which is a W3C body. Technically, it's not a standards group. It's not on the standards track, but it is a place where we're collaborating and trying to work together to advance a common web extension platform across browsers. And this group was founded by the four major browsers, Chrome, Edge, Firefox, Safari, or rather their backing companies, Google, Microsoft, Mozilla, and Apple. And we have regular participation from a variety of extension developers as well. Now, as we go through this talk, we're going to be looking at a couple of specific examples, building up extensions and actually seeing them work in browsers. And the goal is that by the end, you'll have seen a number of techniques that will enable you to actually some lessons that you can take and apply directly to your own extension development. We're going to be modifying site content, working with host permissions, injecting scripts or executing scripts in response to user interactions, working with short-lived background contexts, and the persistence issues that arise from there, talking about how to work with untrustworthy content, and then closing out with some general resources. And of course, as I mentioned, doing some Q&A at the end. So let's get into modifying site content. We're going to take a look at the basics of how an extension can interact with a website. That's one of the most common things that extensions tend to want to do. We're going to see how this works in Firefox for Android, Firefox Nightly, and Chrome Canary. And as I said, these should also work in Safari, but we're not going to be demoing those today for time reasons. So the most basic extension, well, this isn't the most basic extension that you could write. The most basic would only have, let's see, I can enable a laser pointer. Oh, so fancy. The most basic extension only requires these top three fields: a name, a version, and a manifest version. So we're slightly more advanced than an absolute minimal extension, but not by a lot. In this, we have a content scripts array. So we're declaring the script that we want to inject into the page. And that's contentscripts.js. And as you can see here, contentscripts.js adds a document listener. So we're just going to show an alert when the script is executed. So let's take that and actually start running some code. Let's see, Visual Studio Code. So content scripts MV2, this is the demo that we were just looking at. And we're going to load this into a web browser. Let's start with Firefox Nightly. So we're going to go to About Debugging. You can manually navigate to About:debugging and then click this Nightly. I just have some shortcuts here to make this process a little bit easier for myself. I'm going to load an add-on and content script MV2. When we select that file, if we now go to example.com and then click, you can see that we got a click at example.com, just as we expected. We can do the same thing in Chrome, popping over to Canary here. They use a slightly different URL, Chrome extensions, and we can load an unpacked extension. You may need to enable developer mode if it isn't already enabled. And again, we're going to use the content scripts MV2 example. And when we go to example.com, I accidentally went to extension workshop. When we click, we will see the alert as expected. And finally, we are going to do this on Android. Now, Android is a little bit different because you can't directly interact with content on Android. You can't, like, I don't know, write files directly to a section of an Android device where a user could interact with it. So we're going to be using this tool called Screen Copy to mirror an Android phone that's tethered to my computer right now. So SCRCPY. And now we have a Pixel phone, my Pixel 3a here, my test device. And if we go over to, there we go. Now, if we go over here, Mozilla created and maintains a tool called WebExt, which is a command line tool that helps build and test your browser extensions. And one of the capabilities that WebExt has is the ability to run our extension on Android. So the command that we're going to execute here is WebExt run, and we're targeting Firefox Android. Now, as we go through this process, we're going to run into a couple errors because you do have to specify a couple parameters in order to actually get the extension to run on Android. So we'll just stumble through that process right here. Actually, I realized that my command line is the wrong color. I want it to look better. So let's go over here and then cd into code samples content scripts mv2. And now when we do web next run our Firefox Android, we will get the a list of Android devices that ADB, Android Debug Bridge, has found, and we can use the Android device flag in order to select which thing we want to run. Now, if there was only one version of Firefox on the device, it would automatically select that. But since we have multiple, the tool isn't sure if we want to run Phoenix or Firefox. Phoenix is the nightly version of Firefox on Android. And in our case, we're going to be doing all of our tests in the latest versions of all of the browsers. So do the same command again, Firefox and APK, and then specify Phoenix. And when we do that, we can see that the pixel loads up and the extension is loaded and running just as expected. When an extension is first installed on Firefox for Android, it'll get this prompt at the bottom where it tells you the name of the extension that was installed, and it gives you an option to choose private browsing. We don't need that, so we're just going to say OK. And then when we click or tap, we can see that the alert appeared. So that is our very simple extension running in all three browsers. And we also just introduced WebEx in order to automate some of our command line execution stuff. Next, let's take a look at manifest versions. So manifest versions. Dun, dun, dun. The eagle-eyed among you might have noticed that when we pulled open Chrome and loaded the extension, we got an errors field here. And if we take a look at the errors, we can see that Chrome clearly states manifest version 2 is deprecated and support will be removed in 2024. And they provide a link to the deprecation documentation with more information on the timeline as well as resources to help migrate. This is really important for us, not just because they've announced that it's deprecated, but as an extension developer trying to create something new, if you want to publish to Chrome Web Store, your only option for a new extension is manifest version 3. So we're going to have to update our extension to use manifest version 3. We can do that by over here in VS Code. Let's clear out some of this stuff that we don't need to see. Actually, I think we have a slide for it. This is the extension as we've already set it up or initially set it up. And the only change that we're going to make is right here. Manifest version, we've changed it from 2 to 3. Now, when we go back into Chrome, where actually we need to update this. Manifest version 2 to 3, save, go back in Chrome, reload. Yes, Chrome doesn't auto clear errors, so you'll need to clear it. And then manifest version 2, did I not hit save? Live demos, folks. Always fun. This version 2, for example. Let's remove that, load unpacked, select the manifest version 2 directory. Well, I'm confused, and it's my best guess is that I'm loading from the wrong directory. Yes, this is based on a talk that I did at myself and Rob Wu did at FOSDEM 2024. We are a different presentation today, and that's why we're not seeing the changes. So now when we open manifest version 2 that we've updated to be 3, now we no longer see that error, and if we go to example domain and refresh, we continue to see it working as expected. So something to be aware of, manifest version 3 is something is a concern that we will have to be targeting that version of the extension platform. And there aren't a ton of differences between manifest version 2 and 3, but there are some key ones. Most notably, in Firefox, manifest version 3 is currently limited to not granting host permissions by default at install time. And we can see that if we go back to our tool here. Where is the thing that I'm looking for? That wasn't it, but it's close enough. CD to that directory. And now we're going to use, we could load everything manually, but in order to save a little bit of time, we're going to use WebExt in order to launch our target browser and get everything working easily. So for example, here is a pre-made command to run our target in Chrome, and WebExt will automatically launch a new version of Chrome with a temporary profile. This is one of the advantages of using WebExt for your testing purposes. It will kind of handle some of the like isolation and consistency, making sure that you're not interacting with sensitive data or potentially giving data away to an extension that's in development. So here we did Chromium. Let's change that to Firefox. Firefox desktop, my mistake. And one of the nice things that Firefox does when you're running in WebExt in a temporary profile like this is the address bar is changes colors in order to help indicate that it is a temporary extension. Now, when I'm on this page and I'm clicking, it's not, the extension isn't executing. And there's a very simple reason. You can see here that the extension icon has been badged with this little green icon. That's indicating that the extension could run on this page, but it isn't currently allowed to. So if we go into Manage Extension, you can see that in the permissions area, access to your data for all websites is currently disabled. It's disabled by default in Firefox. And now when we go back to this page and reload, the extension is enabled. So that behavior, the fact that the extension doesn't run by default, is something to be aware of and that you'll need to account for in your onboarding flow or when acclimating new users. They need to take an additional step in order to actually complete in order to get full access to websites in Firefox. Next couple slides are going through that exactly. So one of the ways that you can adapt to this change is by adjusting how the extension works. Obviously, what we just saw here was like going into the management and manually controlling the site access grants. We can also do the same thing in Chrome. So I'll show that real quick. Chromium, my mistake. In case you're wondering, if you're testing in Chrome and you want to target other Chromium-based browsers, you can specify a different Chromium binary path using command line arguments in order to, for example, launch Edge. But you'll still need to use target Chromium for that. If you don't specify a specific version, specific Chromium binary, by default, WebExt will use Chrome Canary. And I misspelled Chromium. Now here in the extension, we can manage the extension and then site access, allow on all sites. Chrome has been exploring for a while a change that will change the default host permission grants for all extensions, or it may change the default host permission grants for all extensions. They're still experimenting with it. But the key thing to call out here is that you can emulate the same behavior. It's possible for end users to restrict host permissions in either browser by manually going into the site settings and adjusting one of these values. So now, for example, if we go to example.com and then try to click, the extension doesn't do anything because, again, it has been instructed to only run on click. And the way you would do that in Chrome is by clicking the extension. Now the script has been executed and you can trigger that. Right. So sorry, getting a little too far afield. Let's get back to how you can adapt to this difference. And we do that here with the content script MV3 options UI. Open an integrated terminal. That's the one I was looking for before. So now that we have the example open, we can again run this in Chromium. And the key thing here is that has changed is in our manifest JSON, we have added this options UI page to options HTML. So the extensions options page is currently embedded in the extension management UI. And we can control whether or not the site, whether or not the extension is allowed to run using, using this UI. So when the extension doesn't have host permission access, you can see that the box is disabled. And if you click it, then it will prompt you to grant the extension access. And due to just kind of the way browser extension implementation stuff works, you can't unclick it. So the user can manually through this UI go to onClick and then choose to allow access to example.com. But they can't revoke it from this UI. And the same is true in Firefox. Let's take a look here. Firefox desktop. Oh, what did I do wrong? Why? Oh, given argument target given. Oh, I see. I accidentally deleted too much. I deleted the URL property. So now when we launch Firefox, we're taken to the options permission UI. You can see here that that we have the option to grant the permission. When the user clicks it, they will be prompted to grant the permission. And Firefox also allows you to revoke the permission. So the user will get re-prompted every time. One small note here that I want to call out about the way this has been implemented. Here we have the background color of the page has been inherited from the theme. So by setting in the options page, the meta name color scheme and content dark light, we're saying that the extension page can be rendered either in dark mode or light mode. And we're deferring to the browser to choose which theme to use to render the page. If you're wondering why it doesn't cover all of the content, that's because the body is in HTML is automatically collapsed. It doesn't fill the full height of the viewport. So that could be fixed through CSS if you wanted. But this is a a cool way to get your extension to feel more integrated into the browser and to the user's preferences. But I want to go back a bit and talk about how this has been implemented. So in the options page, we have uh, an origin that we're going to request access to, example.com. And we have a checkbox that when clicked, we're going to render permissions and we're going to call render permissions to render the permission request. And then we call browser.permissions.contains in order to see if the checkbox has been checked and then use that to set the checkbox's value. So this call is the initial render function. So when we, over here in Firefox, when we first load the extension and we see it like this, because Firefox doesn't grant the permission, it's disabled by default. That's how we got this content. Next, we need to actually wire it up in order to reflect changes when the browser, when the user grants permission. So first, we have the checkbox unchanged. So if the user clicks the box and the value changes, we will check if the checkbox is checked. And then if it isn't, then we will, or if it is, we will check if we will attempt to request the permission from the user. The permission here is this example.com pattern. And if the user unchecked it, so if the checkbox was not checked, no, if the checkbox was checked and it has now become unchecked, then we are going to call remove in order to remove the permission. And then this case, as I mentioned before, covers Chrome's refusal to remove the permission. The reason that Chrome refuses to remove the permission is that it is declared here in content scripts matches. So this is like the extension is kind of saying in its declaration, I have to run on this domain. Here is the specific, the actual code. Right. And for Android, we can see the same kind of experience, going to the three-dot menu, clicking add-ons, tapping the extension, and then inside the extension settings, tap settings and allow access and allow. So this is a very manual flow, obviously. You can adjust this to uninstall, automatically open the options page as we have in this demo. And then the user will be able to choose to enable it straight away. Right. Next up, let's talk about script on click. Everything that we've kind of done so far has been automatic, that we're automatically injecting the content script and we're making sure things are running as quickly as possible. But that can also add additional taxes to the user's device. It also requires additional permissions that the user has to actually grant permissions in order to access the site ahead of time. A more privacy-respecting way to approach this is to only inject scripts in response to events that are relevant and signal that the user is trying to take action on the current page. So in this example, we're going to be going through the process of using the extension's action listener, the action being the button in the toolbar, in order to actually trigger it and see it working on a page. So the first thing we're going to do is update our permissions to include two new permissions, active tab and scripting. Active tab is a special tab, it's a special permission that grants the extension access to the user's current tab when the extension is invoked. And scripting is a permission that doesn't display a warning, but it signals to the browser that the extension wants to use a particular set of features. In this case, the ability to execute script dynamically. And I mentioned the action, the button in the toolbar. This is going to be, we're setting a default title. So when you mouse over the extension, you can see something that will describe what that button does. And finally, in order to actually handle and respond to logic in the background, we are going to declare a background script. So there's a small note here at the bottom that right now, the code that we're looking at will work in Firefox, but not Chrome. And we'll address that in a moment. So in the background, we're going to use this polyfill in order to address the incompatibility with Chrome, or one of the incompatibilities with Chrome. Chrome currently uses the global Chrome as the namespace on which all extension APIs are exposed. And Firefox and other browsers use the global browser as to not be browser specific. We have some agreement in the web extension community group that moving forward, Chrome is going to adopt browser as the standard or as the same interface that everybody else is using in order to reduce some of these polyfills that you need to do in order to expose make things consistent across browsers. But right now, this is required, and hopefully in the coming months, it will no longer be. So 2 quick notes about what we're seeing here. First, as said here, in order to save space, instead of using 3 lines to do this simple polyfill, we're going to be using a nullish coalescing operator, the double question mark equals, in order to, this is nullish coalescing assignment specifically. So basically this line does the same thing as what these 3 lines do. So it's just going to save space in future slides. And finally, this polyfill, if you can call it that, is extremely simple because in Manifest v3, Chrome added support for promises in various APIs, and Firefox already had that. So this is, again, reducing incompatibility between browsers. If you do need to target Manifest v2 for some reason, then I'd recommend using the web extension polyfill. That library is developed by Mozilla and polyfills the Chrome APIs to use promises in order to reduce incompatibility between implementations. Right, so in our background script, we're now going to set up a listener on the action in order to actually respond to and inject a script dynamically in response to a click event. And we do that by calling browser scripting execute script. You have to provide a couple of pieces of information in order to actually perform this. Notably, you have to specify a target. In this case, we're targeting the ID of the current tab that the user is on, which is received from the on-clicked event listener. And then the function that we're going to execute can either be declared as the script that's going to be executed can either be declared as a file or as a actual function object. And that function object will be serialized and then executed in the page. So here we're going to declare a func that is the same script that we were running before, alert script ran at document URL. One important thing to note is that due to the way the serialization works for func, you can't use the method declaration shorthand. Like if we didn't have this colon here and it was just func parenthesis, that wouldn't serialize correctly. So you have to, at least for now, explicitly declare a func property with a function body. So let's see this in action. Script on click 1, I believe, is the folder that we want. Just double checking that browser undefined. We set browser and action on click, etc. And then the manifest scripts. So let's now run this in Firefox. That's right. You need to close that directory and open an integrated terminal. So now when we run WebEx desktop on example.com, we have the extension here. I'm going to pin it just for demo purposes. And when I click the extension, you can see this is the default extension icon. When I click the extension, click button and ran script at example.com. So the action has been clicked and the event fired as normal. And this didn't require granting additional permissions by going into the extensions management. Just to show, there are no special permissions being requested by the extension. And if we, again, take a look at the manifest, there is no static declaration of sites that the extension is interacting with. This right now will just run anytime the user triggers the extension action. If we go to Chrome, we should encounter an error. Hit Firefox. I just remembered. Maybe we won't encounter an error. So script on click, and now if we click the extension, yes, it is not working. Chrome extensions and script on click. In the Chrome extensions list, WebEx Reload Manager is, as the name says, an extension that's automatically loaded in Chrome in order to reload extensions when the content on the file system changes. And that's part of the WebEx tool. So you won't normally see this one unless you're using WebEx. So the reason that this isn't working in Chrome, despite its lack of errors, is that the extension Chrome uses a different background context than Firefox for its scripts. If we pull up manifest JSON here, we can put these two side by side. Here you can see that the Chrome version uses service worker and the Firefox version uses scripts. So now if we go into Chrome, so the script sample click 2. Now, if we do the same thing in Chrome again, this version will work. When we click, the script executes and it runs successfully. So we have this issue now in our cross-browser extension development, where we have two different ways of trying to declare a background context that's going to work in both browsers, but neither one works directly. As of Chrome 122 and Firefox 122, purely coincidental that those version numbers line up, it is now possible to use both of these in a single file. Previously, you could only have one, and then that would lead to a situation where you couldn't have a single code base that worked in all browsers. But that is no longer the case. Now we can have scripts and service worker both declared in the same file. And this gives you an opportunity to, if there is some difference in behavior that you need to implement for Firefox and Chrome, this gives you a way of specifying a different entry point for the other browser. So if we now go to Quiz this out. CD script on click, and then rerun in Chromium. We can see that the extension triggers as expected. And if we switch to, I feel like I probably should have made target the last parameter. That way I don't have to go into the middle each time. Anyway, we do Firefox desktop. We can then trigger the extension and it works as expected. And just for kicks, let's do Firefox Android. Oh, right. We have to specify all of those additional parameters. Let's save time by copy paste. And now if we go back to screen copy, we can see that the extension has been added. And if we trigger add-ons, execute script on click, it executes immediately. So that's working as expected across all of our different targets. Yes, here I prepared two different versions, one for when not doing live demoing and one for live demoing. Here you can see that background scripts and background service worker are together in the same file. Right. I mentioned the version number thing. Apparently I was wrong. It isn't 122, it's 121. In order to get this, in order to ensure that browsers that don't support this feature don't get loaded, that the extension doesn't load in them, we have this these additional lines added to the end. Browser specific settings and minimum Chrome version. Minimum Chrome version, as the name implies, specifies the minimum version of Chrome or Chromium that is required to use this feature. So if a user is on 120 and you push an update to Chrome Web Store, the users won't download that version. Those users won't download this version. Similarly, browser-specific settings is Firefox's mechanism for declaring this, and you can specify both Gecko and Gecko Android. Both of them have a strict bin version field, and here 121.0.1 means nightly. So nightly is the first version that actually supported this feature. And if people are using, for some reason, versions of nightly that are that old, they could. This feature should work in it. So we have talked a bit about being able to load your background context or your background script in multiple different browsers and consistently. Let's take a look at how a more complex application could compose multiple scripts and execute them in a single browser. This pattern that we see here, background scripts with an array and using some library and background JS, that predated Manifest v3. It was something that you could do with event pages or persistent background pages in Manifest v2. But because Firefox and Safari continue to support the scripts array and event pages, you can continue to use this shorthand to include multiple different files. In this case, we're going to use a different entry point for our service worker. So rather than background.js, we're going to have service worker, our extension service worker load sw.js. And then in the service worker script, we're going to use import scripts to import an array of files. Import a series of arguments of files. And this will achieve effectively the same result. The difference here is that with the scripts-based approach, the browser is dynamically generating a background page, and for every script that you declare, it's adding a script tag to the head of the document. Whereas in a service worker, because it's a worker, it doesn't quite have the same loading semantics. So you have to manually create import scripts. script on click via extension pop-up without a background. So we just walked through an example where it was possible to dynamically inject a script into a page with by clicking the extension's action and then triggering something. But there are other ways that you can do this as well. An extension does not necessarily have to have a background page. It's a very common pattern, but it's not required. In this example, we're going to implement a pop-up that will trigger the script execution on the page. So in this case, we had a default title for our action before. Now we're introducing a default pop-up, action HTML. And in our pop-up, we're going to have just a script that loads a script tag that loads our script as a module. And then in our module, the reason that we're using a module here is because we want to use top level await. Without modules, if we didn't use a module, we would have to declare an async function and manually invoke it. So this is just a little easier. Anyway, in the pop-up, in the script pop-up logic, we are going to, as soon as the pop-up opens, call browser tabs query to get the current tab, active true, current window true. So we're going to get the active focused window that the user is interacting with. The pop-up itself is another window context. So we need to make sure that we're grabbing the main document. And then we're going to use browser scripting to execute a script. Here, before we had a tab object because the user was invoking the action. But now, because we're querying for it, we're going to get the 0th entry. There should only be one entry in this response. And we're going to grab its ID. Again, that function is serialized in the context of the tab. And here, this is actually addressing a bug that we discovered while, that we encountered while preparing this demo, where on Android, you could potentially get into a situation where the alert tries to get called before the page could actually display it. So it kind of broke things. So let's see this guy in action. And script on click without background. As before, let's do Firefox first. So when we invoke this extension now, oh, right, it happened so quick, I forgot what was even happening. Let's go through there again. When we click at this, there is, for a very brief moment, a pop-up that appears here. And then when the alert appears, the pop-up is dismissed, and the focus moves away from the pop-up to the page. And when the focus shifts, it automatically closes the pop-up, which is how we ended up with this behavior here. But the important thing is that the extension, when you click it, it still executes the script as expected. Let's switch over to Chromium. That was a little more visible for me. I don't know if it's going to come through on the video or the recording, but there is, for a flash, the pop-up appearing. I think I may have actually had a screenshot with it as well. Yes, so here you can see in Firefox, this is the pop-up, very small. This isn't normally what you would do, but it is a thing that can happen. And then finally, let's take a look at uh, Android. Firefox and Android. I can spell. I can't spell. Oh, no, I can spell. It's just a longer command, which I forget every time that I don't just re-execute the same command. Um, Small tip, if you are regularly doing something like this, I will personally sometimes set up like a bash script or something um, to manually trigger that. That way I can just do like run dash Android and it will give me exactly what I'm looking for. So again, script without background has been added to Firefox nightly. When we now trigger add-ons and then execute script on click, ba-ba, you can see there was a brief moment where it faded, where there was like an arrow button in the top left, and there was like a fade transition. That's because the pop-up is displayed on Android as a actually let me just pull it up real quick. Since we're live coding, we can do some weird stuff. We have finally Windows close. We're just going to skip the close, so we don't have that. And now when we go back to Android, oh, that's curious. Why won't it give me my taskbar back? All right, well, I guess you're just going to see my list of tabs. Now when we go back over here and trigger the extension, I think the alert is still taking over. Finder, help me. There we go. Oh, add-ons, execute. I wonder if it is this timeout. Checked immediately, set timeout. So I mentioned we fixed a bug by adding that. You can see that when we saved, it automatically reloaded. And so we should now see different behavior. Because the alert is trying to be called while the pop-up is up on the same turn of the event loop, that causes the pop-up, the alert to be called in a context in which it doesn't matter. It tries to get called in a context that isn't visible and therefore can't display an alert. And that leads to this behavior that we're seeing. But if we use the set timeout, that will allow it to add-ons execute and also re-add the close. I think we're maybe lagging one version behind on the changes. Well, that's the beauty of live demos. I'm not sure what just happened that caused the pop-up to no longer appear. Just undid everything and rerunning it uh, in order to make sure that the demo as we wrote it actually works as expected. All right, that's all great. Let's head back over here. And the example of how to run it on Android. So another common issue that developers are going to be running into with Manifest v3 extensions in particular is short-lived background contexts. I mentioned before that Chrome uses Service Worker and Safari and Firefox use an event page. The critical difference between Manifest v3 and Manifest v2 here is that Manifest v2 supported persistent background pages, which conceptually are just a headless page that exists for the duration of the browser session. And once that session ends, then the page is terminated. For resource constraint reasons, and limitations outside of the browser's control. All browsers are moving towards this event-based approach where an extension background context will be started, it will run for a bit, and then it will be terminated when it's idle, or when it doesn't have a choice, when the system forces it to close. That is especially a concern on Android, but it's technically possible on any platform. So let's talk about how to work around that or work with that constraint. Here we're going to implement a visit counter that shows the number of times somebody goes to extensionworkshop.com. And when they do, the number of visits will be displayed in the action on the toolbar. So to implement this, we're going to use web navigation to observe when navigations occur. Seems logical. And we're going to use storage in order to persist the value, the number of visits. We declare an action, so we have the action button available. If you don't declare this, it's kind of action in the manifest is kind of implicitly a permission request. If you don't declare an action object in the manifest, then it won't be exposed. Like the JavaScript APIs won't be there. So you have to tell the browser that you want to use action by declaring that in the manifest. And then in the background, we're declaring our background script for both Firefox and Safari and for Chrome. So in the initial implementation here, we're going to start with, we have this grayed out browser global Chrome thing because we always have that. But we're going to have a counter that's just a global object. And whenever a web navigation occurs, we are going to increment the counter and then set the badge text to the new counter value. This here is if you haven't seen this pattern, empty quote plus number, it coerces the number into a string. And browsers, for better or worse, expect the text property to be a string. It doesn't, like many other web JavaScript APIs, it doesn't implicitly convert it for you. So that's why we have this equals plus thing, or quote plus thing going on. And then in the web navigation API, we only care about visits to extensionworkshop.com. So we have an array of filters, and the only filter that we declare is host equals extension workshop to limit it to that domain. The problem with this implementation, as this big warning clearly indicates, is that the state is lost when the background terminates. So if you're browsing around the web, you go to extension workshop, you navigate away, the background context gets terminated. Next time the script starts, it will re-execute top to bottom. And count will again be initialized to 0. So there's no persistence of this data. So we're going to fix that. We still declare count, we just don't initialize it with a value, because we're going to check the value of count. And if it is nullish, we will fetch from browser storage the current count. This syntax here, get count :0, this says that if there isn't currently a value count in storage, in session storage, set it to 0. Or sorry, fall back to the value 0 when returning a response. So the items object will contain a count property, and if there wasn't a count set, it will receive a value of 0 for our internal use. So we get the count, we increment it, and then we set the new value in storage, and we await that value resolving in order to make sure that things are settled and that our state is accurately represented in the future. And then we display browser actions at badge text count. We'll update the badge text with a count. So there is a potential problem here in our implementation that multiple events can lead to reinitializations of this. That's not ideal. And it's probably less likely, but the scenario where this would occur is, imagine you clicked a link and it then spawned 2 tabs at the same time that went to Extension Workshop. That would trigger 2 events. And in both cases, count would be initialized to 0 when the background script first runs. But this async handling of count. Because we have to get data from storage, that takes time. So when both events are received by the background script, count will not be defined, and it will try to trigger two events, two loads in parallel. So the way we can work around that is adding a little bit more complexity, but we introduce a count promise. And if there isn't already a count promise, we will start the process of triggering a session storage get call. Then we will await the response and then extract the item count from that, and then finally null out the promise. So this ensures that if there are multiple that are triggered at the same time, that they will all check for a promise to resolve, and only when it's resolved do they perform their work. So let's take a look at what this looks like in Firefox. Actually, we're going to quit nightly and then go back over here to our visit counter. cd visit counter. Let's not do Firefox Android. Let's do Firefox Desktop. So we're on example.com. Let's pin this to the toolbar. This is our visit counter. It's a little hard to see under my jumbo pointer. And if we go to extensionshop.com, we see 1. If we open a new tab and go again, oh, we see 2. Now, if we go to about debugging, we have the option to manually terminate the background script. It will get terminated if we wait long enough, but we're impatient developers that want to get stuff working with minimal time. So we manually stop it. And now if we, again, trigger another navigation to Extension Workshop, just by navigating a link, you can see 3 updated, Extension Basics 4. And again, we can terminate it and then continue to trigger. So this value continues to update and reflect our state as expected. This kind of thing where we're implementing this background script and manually implementing these checks can be a little bit complicated. And in cases like this, I'd encourage you to either write your own or find a library to help with this, just to gloss over the details, let you focus on writing code that works, writing your application logic rather than trying to make sure that you're keeping track of session management stuff. Yes, demo pictures. Yep, you can see numbers are changing. Oh, I do want to quickly show in Chrome where the equivalent functionality is. So let's go back to Chromium. Chrome extensions. There we go. So here in details, we need to enable developer mode. We can see inspect service worker and visit counter, extensionworkshop.com. And there we go, V1. Application. Where is it? I'm trying to remember. I thought there was a stop button, but I will show the Chrome service worker internals. Service worker internals is a debug page for Chromium developers, but you can also use it to manually interact with the extension background. So here we can stop it, and we can see that service worker inactive. And again, here is background scripts, requires manifest for 2 or higher. This, that error message that we just saw, this is actually a warning. Well, Chrome doesn't support background scripts in manifest v3, but it doesn't error. You can still load it, but you will see this warning when looking at the log. Similarly, browser-specific settings, that is a field that's used by non-Chrome browsers. So Chrome doesn't know what it is and lets you know that it doesn't know what it is. So again, service worker, we can see that the service worker is inactive. And then if we trigger another navigation, stop it. Stop. Trigger another navigation. Value is 3. So all of that is working as expected. Cool. Back to the presentation. Untrustworthy content. In this case, we're going to take a look at an extension that is going to perform some basic content blocking and interacting with web pages in a way that you might not normally. So as before, we have a content script that we're going to automatically inject into pages. And we have xstyles.css, which is a style sheet that we're going to inject into a page in order to hide content that we don't want to see. The content script is going to implement a couple of things. Sorry, I just remembered a little bit of additional context. Untrustworthy content, one of the things that extension authors sometimes need to be aware of is when interacting with web content may not want you to be there. The website may be hostile. It may try to stop you from doing things or make your life more difficult. In those cases, you may need to shield the internals of your implementation from the page itself. So in this case, we're using a div with a shadow root in order to close over content that we don't want the page to be able to interact with. But because we're exposing UI on the page, we have to add some DOM content to the page. So in this case, we have a shadow root that is closed, so the page, so other script can't interact with it. And then we're going to append the UI and add a style sheet and etc. The web accessible resources here, extensions can't normally, or web pages can't normally access an extension's content because that is potentially a fingerprinting technique for websites to see that an extension exposes some resources and then know exactly what extensions the user has installed. So in order to prevent that, extensions by default, their resources are not accessible to the web. And therefore, you have to manually declare web accessible resources to expose assets to web pages. And this requires a bit more discretion and understanding on the part of the extension developer. But that's why we have to manually declare xstyle.css. That is a file that we want to be accessible to websites, that we want websites to be able to load from the extension. And in this case, we're using browser runtime get URL to determine what the URL of that file is when we append it to the document. Because in Firefox and Safari, the extension's URL is dynamic. Every time the browser starts, extensions are assigned new IDs. Chrome, I believe, is working on a feature that will allow extensions to opt into dynamic URLs when inserting assets for web accessible resource purposes. But in Chrome, extension IDs are static. They're derived from the private key used to sign the extension. So details aside, in this case, we are going to declare our style CSS where the host of the thing that we're injecting into the page, the div, sorry, the shadow root. We're going to style the shadow root of the custom content that we're injecting into the page in order to add something fixed to the page, give it a little backdrop, make sure it's positioned in it's covering all content and it's drawn on top of everything else with this Z index. The last thing to note for CSS ordering purposes is the stacking context. In order to ensure that this is drawn on top of everything, we're also going to put it on the root of the document, which you can see document.createElement, div.shadow root, document.body.append. So this is in the, it's a child of the body. It's going to be, nothing else can potentially occlude it. And then this is the manifest for the, I think I missed a slide there, but that's fine. Let's take a look at the right. So this is the extension we were just looking at, soft content blocker. And all of these demos, they're currently in a separate repository that Rob Wu created when preparing these demos, but we're going to be merging them into the web extension samples repository in the coming weeks. So now that we have this open, let's target Firefox. Oh, right. Sorry, we need to cd into the new directory. Soft content blocker. Then let's webx run. So this soft content blocker, it just adds this overlay to all of the content, and then we have to click the button to reveal it. And here you can see that the shadow root closed, that this is being positioned as described, top left, etc. So this will apply to any website we go to, google.com. All the content is blurred. Oh, Google is doing something a little interesting. Click to reveal content. Oh, sorry. Google isn't doing something interesting. We're still drawing on top of everything. And the blur is how the soft content, it's a soft blur, is blocking. So that covers content interacting with websites and potentially hostile sites. Next, we're going to take a look at a simple content blocker that is using declarative net request to modify, to block requests that are coming through. And this demo uses an options page in order to expose some controls. So in the options page, we're using a pretty simple thing here, but you can see it specifies new line separated list of URLs that you'd like to block. Wildcards are supported. So the user can manually declare which URLs they want to block, or to extrapolate on this example a little more, an extension could dynamically respond to user interaction or its own application logic in order to decide what content is added or removed from the content blocking list. So let's take a look at the demo. Request blocker with options UI. Request blocker with options UI. Apparently, we're going to load it in Chromium this time. So when the extension is installed, we're going to pin this guy just to make it a little easier. We can open the options menu and manually add and remove our domains that we want to block. So for example, I could do star.example.com. Did I spell that correctly? Save changes. And now if I go to example.com, it worked and it shouldn't have. Oh, I wonder if it's because I did the wildcard or star dot save changes. And then this, maybe it's cached. Well, I think I'm going to bail on the live demo because it is apparently not working. So let's look at screenshots. We load a temporary add-on. We see the extension is enabled. We go to preferences and maybe I was truncating the host too much. Let's copy and paste that into here. Save. There we go. Example.com is blocked. So you could set up rules that are less strict than what we just did. In this case, you have to include the protocol, and I forgot that. So you visit example.com and you can see that the request is blocked by an extension. Just to show that live in the network panel, when we request it, the reason here is blocked other. And I believe Firefox indicates that it is the request is blocked by an extension. I think actually the other may be relatively new. Now I'm just opining, but all right. That's enough of that. So I mentioned a couple of resources that I'd encourage you all to check out. Extensionworkshop.com is the website that Mozilla maintains on how to build extensions for Firefox. WebExt, github.com/Mozilla/WebExt is a CLI tool that makes it easier to develop your extensions and iterate on them. Mozilla also maintains the add-ons discourse.mozilla.org/add-ons /c/add-ons and blog.mozilla.org. We're trying to make a point of posting there more regularly and giving you all some interesting content to read. And finally, if you prefer chat, Mozilla maintains the pound add-ons group on Matrix, on the Mozilla hosted Matrix, chat.mozilla.org. Or you could use this Matrix link in order to jump directly to the channel. Rob Wu did a lot of work on this presentation. Many thanks to him for his contributions. If you have questions or comments for him, you can email him directly, and you can reach me on Twitter or less and less these days, on Mastodon, or less and less these days on Twitter. And with that, I think let's jump over to some questions. And
Simeon, great job today. I think there were some permission issues with the questions.
Oh no.
It's fine though. I've been able to aggregate the questions. There's only a couple outstanding ones that haven't been addressed. Do you want me to just read them to you?
Yes, please. Also, the voice from the ether is Ed, our
Hi, folks.
developer relations and community manager. He is has been kind enough to be running some stuff behind the scenes during this talk. So yeah,
So, at
questions.
around the 45-minute mark, if the context held, why does Chrome not rename its variable from Chrome to browser?
Uh, so the simple answer is historical reasons. That's not a very satisfying one, and that is why um, we we are in the process in the WECG of creating uh, a spec doc that will actually describe the browser global as something that's related to web extensions, and that is deferred to browsers to implement as they choose. Chrome will be adopting the browser global in the future.
Thank you. And one more, and this came in about 10 minutes later at the 55-minute mark. When Firefox DNS ECH in Android in the Android normal version. If that doesn't make sense, maybe the poster could clarify, and I could pass that along to Simeon.
Yeah, I'm not quite sure. So Firefox does have a DNS API, MDN Firefox DNS. And this isn't exposed in other browsers, but I'm not sure what the ENS part of that question was referring to.
Yeah, I'm sorry, that's all the context I have.
No worries.
Well, that came in from Juan. Juan, if you're still on, Simeon did post some ways to reach out and contact individuals or post in our forums. So if you still have any outstanding questions on that, please feel free to post them.
Yeah, absolutely. Any other questions, Ed?
Let me take one last quick pass through all the various streaming platforms. Nothing there, nothing there. All set, sir.
All right. Well, again, if you have any questions or thoughts or feedback, I am extremely open to them. We don't, I need to do a little bit more cleanup on the slides before I make them public, but I will try to keep this same URL and publicly publish that. What else was I going to say? Um, I'll also try to make a PDF version of the deck available, and we'll attach that in the comments on the various places that this video is available. So future reference, you can see exactly what we were talking about. And finally, if you have any questions, I'd especially encourage you to reach out on the Mozilla discourse, discourse.mozilla.org. I try to go there frequently and answer questions about extension development. You can see my face on a lot of these posts. All right. Well, with that, thank you all for attending, asking questions. Apologies for the bug with the rights on being able to comment. And I look forward to doing this again in the future. Hope you all come again in a month or two. Take care.